Hello everyone, today I want to explain about the diastereomers. One of the example 2,3 pentane diol. This can be drawn as like this. Now this is a OH and this is a OH. This is H and this is a CH3. This carbon. At this carbon we have hydrogen CH3 and OH. This carbon bonded to this CH. Now this is H and C2H5. Now based on that we will get the different form. Just observe that form, and this carbon is chiral. Chiral meaning what is that? Around this all atoms or groups are different. Now this is a hydrogen, this is a hydroxy group, and this is a methyl group, and this whole is the another group, so different is there. Similarly here hydrogen, and next hydroxy group, and then ethyl group. So this is the different groups bonded to this central atom. Then this is a chiral. So how many chiral carbons are there? Two chiral carbons are present. Now these are the different form of the given structure. Then here second carbon we have, this is second carbon and this is a third carbon. So number given here, this is a third, this is a second, and here configuration is S configuration, S configuration, and here S configuration. Here R configuration, here R configuration. Therefore 2S, 3S, 2R, 3R. Now if you place a mirror in between them, then these are the mirror image to each other, because this CH3 mirror image, OH mirror image, and this H and this H are mirror image. Now these are mirror image and this is mirror image. Hydrogens are mirror image. Therefore these are called enantiomers. Similarly here, this is a S configuration, R configuration, R configuration and S configuration. Now you have to check that these are the mirror image or not. This is a mirror. OH is same, CH3 and H. Next here H same is there, and C2H5 OH. So these are also which one? Enantiomers. But if I place here mirror in between the first and second structure, then these are mirror image or not, just we have to check. OH mirror image, but here what is there? C2H5, here what is there? CH3 is there. So this is not the mirror image to each other. Take the second structure and place on the first structure. They are not exactly superimposable. Therefore these two are called diastereomers. And these two also not superimposable to each other. Therefore this is also called diastereomers. Now keep in mind, diastereomers mean what are the isomers which are non-superimposable to each other, and they are not mirror image also. Neither mirror image nor superimposable are called diastereomers. So that is only I mentioned here, that first structure and second structure right side is mirror image to each other, and these two are mirror image to each other. Therefore these are enantiomers, and these two are called diastereomers. These two are called diastereomers. Now this diagonal also diastereomer, this diagonal also diastereomers. So now you should know that keep in mind which one, R configuration, its mirror image is which one? Yes. In case yes is there, mean its mirror image which one? R. Therefore these are called enantiomers. This is an enantiomer configuration. In case here R yes is there, meaning here first one and second one. So first one respect here S required, second one respect to R required. And here S R mean first one respect to R required, R respect to S. This is also enantiomer. In case R and R, in this one is same, another different mean, that is called diastereomers. So all these are called which one? Enantiomers. Now onwards these are called diastereomers. Now if you consider here yes and yes, its mirror image is in this one is as it is, another is different means these are called diastereomers. In case here R and yes, then R as it is. Yes is different mean opposite if it is a R configuration mean this is called diastereomers. So keep in mind when more than one chiral centers are there, in that any one of the same configuration and remaining are different meaning they are called diastereomers. Enantiomer meaning what is R opposite yes required, yes opposite R required. Such type of configuration is called enantiomers. Now, properties. What are the properties of diastereomers? Diastereomers differ in all their physical properties. Thus, diastereomers have different melting point, boiling point, heat of formation, and standard free energies. Because diastereomers differ in all of their physical properties, they can in principle of separated by conventional means such as fractional distillation or crystallization. If diastereomers happen to be chiral, they can be expected to be optically active, but their specific rotation will have no relationship. Then you may get the question here. Diastereomers happen to be chiral. So now whatever we discuss, they are chiral because some diastereomers are achiral also. For example, cis trans configurations are also which one? Diastereomers. So they don't have the optical activities. That's why this word mentioned here, diastereomers happen to be chiral. They can have be and they can be expected to be optically active. In case cis trans isomer, they are just geometrical isomers but not optically active. So their specific rotation will have no relationship. If it is a D, then another is L. There is no relationship between the diastereomers. So this is about the a clear information of the diastereomers.